So this is a Bohr model worksheet where we are given 6 elements, and for each element we have to fill out the Bohr model for each element. Again, the Bohr model is a diagram representation of the electrons and how many electrons there are in each shell of a given element. So if we look at the periodic table, we see that sodium has 11 electrons. So there has to be 11 electrons for sodium. So let's put them around the orbitals. So we look at the periodic table. It has 2 electrons in the first shell, has 8 electrons in the second shell, and 1 electron in the third shell. So that is the Bohr model for the sodium element. For potassium, if we look at the periodic table, potassium, which is K, has 19 electrons. So putting them around the potassium nuclei, it has 2 electrons in the first shell, 8 electrons in the second shell, 8 electrons in the third shell, and 1 electron in the fourth shell. If we look at hydrogen, hydrogen only has 1 electron, and so we just put 1 electron that is in orbit around the nuclei of hydrogen. For carbon, carbon has 6 electrons. So putting them around the ring, carbon has 2 electrons in the first shell and 4 electrons in the second shell. For silicon, looking at the periodic table, silicon has 14 electrons. So 2 electrons in the first shell, 8 electrons in the second shell, and 4 electrons in the third shell. For oxygen, oxygen has 8 electrons. Two electrons in the first shell and 6 electrons in the second shell. Okay, so under each of these Bohr models, I will also write the electron configuration for each of these elements. Sodium, 1s2, 2s2, 2p6, 3s1. So as you can see, these are the 11 electrons, but now because I've written the electron configuration, they also specify which subshell they belong to. These subshells, S, P, D, and F, tells you the shape of each of the orbitals. Whereas in the Bohr model, it is oversimplified. So the electron configuration gives you a better view of exactly where these electrons are and under which subshell. For potassium, the electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Hydrogen, very simple, has only 1 electron. That's in the 1s1. For carbon, 6 electrons, but they are in the 1s2, 2s2, 2p2. Silicon with 16 electrons, 1s2, 2s2, 2p6, 3s2, 3p2. And for oxygen with 8 electrons, 1s2, 2s2, 2p4.